Hey guys, Miss Bendon again. Today's aim is how do we interpret quadratic equations in vertex form? And your do now is to rewrite the equation below in standard form. So you're going to do a little bit of distributing. My hint to you is that x plus 2 squared means x plus 2 times x plus 2. All right, so we're going to rewrite this as f of x equals x plus 2 times x plus 2. And then on the end of that, we've got our plus 3. And we're going to go ahead and distribute this x plus 2 times x plus 2 because we've got two things multiplying in parentheses. We know that to distribute, we're going to need to either use the box method or FOIL. I'm going to do FOIL on the screen just because it's a little bit faster and shorter. But if you did the box method, then you rock. I actually think the box method is probably better mathematical practice. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. And then we still have that plus 3. So we're going to combine our like terms here. And for like terms, we've got this 2x and this 2x, and we also have this 4 plus 3. So we have f of x equals x squared plus 4x plus 7. Okay, so now that we have that in standard form, let's quickly go ahead and find the axis of symmetry and the vertex, just like you got into, or just like you learned to do, and hopefully already did the delta math on in the previous video. So to find the x value of the vertex and the axis of symmetry, we're just going to do x equals negative b over 2a, which in this case is negative 4, because I've got a positive 4 as my b, which becomes negative, over 2a, which a is 1, so that's 2 times 1 is 2, so x equals negative 2. So x equals negative 2 is my axis of symmetry. It's also the first coordinate of my vertex, or the x coordinate of my vertex, I should say. So then to find y, I'm going to plug in negative 2 for x, and I've got negative 2 squared. Got to put that in parentheses if I'm going to put in my calculator. Whoops, what am I? Plus 4 times negative 2 plus 7, and that's going to give me, see, negative 2 squared is 4, minus 8 is negative 4, plus 7 is 3. So my vertex is at negative 2, 3. So we found our axis of symmetry and we found our vertex. When we look at that vertex and then we look back to this equation the way it started before we simplified it, do you notice a relationship between the vertex and the two numbers in this non-standard form equation? So we've got a positive 3 as our y-coordinate, and we've got a positive 3 on the outside of this equation. And then we've got a negative 2 as our x-coordinate, but a positive 2 inside the parentheses of this equation. And so this equation on the left that you started out with is in vertex form. It's still a quadratic equation. We were able to rewrite it in standard form, but we have it here in vertex form. And all the way back in Algebra 1, you guys did learn how to get from standard form to vertex form using something called completing the square, but we're not really going to focus on that right now. We're just going to talk about what information you can get from an equation that is given to you in vertex form. So vertex form takes the form y equals a times x minus h squared plus k for a parabola with a vertex at h comma k and an axis of symmetry at x equals h. You need to get that into your guided notes document. And a shortcut way of remembering it that I use is H lies, K tells the truth, because that K on the outside is going to give us our Y coordinate of our vertex directly. But that H coordinate that's inside the parentheses, notice that it's a negative H inside the parentheses of the equation, but a positive H in the vertex and the axis of symmetry. We have to flip the sign of that H value. So for an example, we have a quadratic equation in vertex form given to us. Y equals x plus 4 squared minus 3. So our H value, oops, is going to be whatever is inside these parentheses, but with the sign switched. So since it's positive 4 inside the parentheses, H is negative 4. And then our K value is going to be this number outside of the parentheses given to us exactly as it is. K tells the truth. So our K value is negative 3. And that means that we have an axis of symmetry of x equals negative 4. And we have a vertex of negative 4, negative 3. So when we get that parabola in vertex form, it's a little bit easier to spot the vertex and the axis of symmetry than when it was in standard form. It is, however, a little bit harder to spot the y-intercept. Remember that in standard form, the y-intercept was just the c value. All right, and then the last thing I want to make sure we go over with this is how to spot the domain and range of a parabola. So quick vocab review, what does domain mean? Great, the domain is all of the x values that are part of this function. And since this is a parabola, it's going on all the way to the left forever and all the way to the right forever, which means that our domain is actually, all those x values are going all the way to negative infinity and all the way to positive infinity, no matter where our parabola is located, no matter what the vertex is, no matter what we do to it. If it is a parabolic function, if it's a quadratic function giving us a parabola, then the domain is going to be all the way from negative infinity to positive infinity, or we might say all real numbers, or we might say negative infinity is less than x is less than positive infinity. And those are all just different ways of saying that the domain is going to go all the way to the left forever and all the way to the right forever, because that's what parabolas do. The range, on the other hand, is all of the y values of our parabola. And the range is always going to involve the y value of the vertex, because the vertex is where we're turning around. So the lowest y value that our graph hits is going to be at the vertex, which means that we can pull the lowest y value out of the equation when it is in vertex form. So for this one, the lowest value we're hitting is negative 3, which means that all of the y values in this parabola are going to be negative 3 or bigger. So we can say y is greater than or equal to negative 3. Or if you like the interval notation better, which I always kind of do, we could say that the y values are going from negative 3 to infinity. Quick note so that I don't give you guys a misconception. If we had a parabola that was turned upside down, which would mean that we had like a negative sign in here, then suddenly this vertex is no longer the lowest point on the parabola. What is it instead? Is the highest point. It's the maximum of the parabola. And if we have, let's say that this is the point 2, 4, if we have an equation where our vertex or our parabola is shifted upside down, then that y value of the vertex is going to stop being the minimum and start being the maximum. So it's going to be the top of our range. So in that case, we would have something like negative infinity to 4 for the one I've drawn, or we could say y is less than or equal to 4 to write our range. So the y value of your vertex is always either the minimum or maximum of your range, depending on which way the parabola is flipped. Let's do one more check-in together before I let you loose to do your delta math. You're going to try this on your own, and then we're going to go over it together. Okay, so the vertex, first of all, we're in vertex form, so we've got our h value is going to be the opposite sign of the number inside the parentheses. So since it's a -1 in the parentheses, h is 1. K is going to be the number outside the parentheses, which is 2. So our vertex is at, what did I just do? Our vertex is at 1, 2. And our axis of symmetry is at x equals 1. The domain is going to be the same domain that all quadratic equations have, and you can write that however you want, but it's got to be something that says that the graph hits all real values of x, everywhere from -infinity to infinity. And then our range, is this parabola opening up or opening down? It is opening up because it's not being reflected. It doesn't have a negative sign. So that means that this y value from our vertex of 2 is going to be the minimum value of our range. And it's going to go up forever all the way to infinity. Or we could write that as y is greater than or equal to 2. All right, guys, give the Delta Math a try. Hope you're doing well. Feel free to reach out with any questions. We are now doing MRS 11 tutoring, so you can always go into that tutoring if you need some help with this. And I hope you have a wonderful day. Bye. Bye.